Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here, and in this video we're going to be looking at triangles. So, by the end of this lesson, you'll be able to name the different parts of a triangle, classify triangles according to their side lengths or interior angles, find the size of missing angles in the triangle, and use the exterior angle theorem. Let's have a look at part 1 of this video, naming the different parts of the triangle. We need to label the vertices with capital letters. Okay, vertices is just the plural of vertex, which are just the corners. So I'm going to label this capital A, capital B, and capital C. We label the sides opposite vertices with the same letter, but in lowercase. So here we've got capital A. The side opposite that is over here. So we're going to label this with a lowercase a. Here we have vertex B. The side opposite that is over there. So I'm going to label this side with a lowercase b. And here we have vertex C. The side opposite that we're going to label with a lowercase c. Alright, so now I'm just going to get rid of all this. And when we name angles, we must always use 3 letters. This angle here is angle CAB. The middle letter is where the vertex is. We could also rename this. So I'm going to write or angle BAC. We can go backwards as long as the middle letter is where the vertex is. Alright, let's have a look at this one. This is vertex B. So that means B should be in the middle. We've got angle angle ABC or angle CBA. Over here, we have, because it's vertex C, C should be in the middle. Angle ACB or angle BCA. Alright. I want you to pause the video, have a go with this question here. Complete the triangle below by labeling the remaining vertex, sides, and angles. Okay, so I'm going to start off with this L, this vertex of L, the side opposite that. I'm going to use a lowercase l. Vertex M, we'll have a lowercase m for its side. This here is a side S. The vertex I'm going to be using is a capital S. Alright, I've got those 3. And now I'm going to name these angles. This has a vertex M, so M will be in the middle. Angle LMS. Okay, I'm using the vertices when I name my angles. This one down here is at vertex L, so L needs to be in the middle. Angle MLS. This one here is at vertex S, so S needs to be in the middle. Angle MSL. Of course, you can just go backwards for each of these ones, so don't mark yourselves wrong if you did. Okay, let's have a look at part 2 of this lesson, which is classifying triangles. We can classify triangles according to how many sides are the same length they have. So an equilateral triangle will have 3 sides of the same length. And we can see that here, indicated by the markings. Every side has only one line going through it, so we know they are all the same length. Equilateral triangles will also have equal angles inside. They are all 60 degrees. Isosceles triangles are triangles with 2 sides of the same length. So we can see here, because these two sides have a marking of one line going through them, and those two are the same length, and therefore they have this same size angles down here. And scaling triangles don't have any sides of the same length, that's why there are no markings at all. Or we can classify triangles according to what kind of angles they have. So if all three angles are acute, like they are here, so that's less than 90, that's less than 90, and that's less than 90 degrees, they're all acute, so this is an acute triangle. A right triangle, or a right angle triangle, will have one of the angles is a right angle. That little square there means it's a 90-degree angle. And an obtuse angle will have one of the angles is obtuse. So here we can see this angle here is more than 90 degrees, less than 180, so it's obtuse. So we can call that triangle there an obtuse triangle. Okay, let's have a look at how to find the size of missing angles in a triangle. Now the interior angles of a triangle will always add to 180 degrees. This is really important because we'll be using that fact to find the size of any missing angles. So let's have a look at these questions. We're going to find the unknown angle giving reasons. Here we've got three angles, 38, 92, and A. They're all inside a triangle, so we know that they are all going to add to 180 degrees. So if you want to work out what A is equal to, we're going to start off with 180 degrees, always whatever they add up to. And then we're going to minus what we do know. We know there's a 38 and we know there's a 92. And let's see what that equals to. 180 minus 38 minus 92 is 50 degrees. So A is equal to 50 degrees, and my reason is the angle sum of a triangle. Happy for you to use those symbols. Question B. Here we have an isosceles triangle, indicated by these markings here, which means that this angle here has to equal to the same as this one down there. This has to be 80 degrees as well. So we've got two A's. We know that A plus 26 will add to 180, so I'm going to start with 180. I'm going to minus what we do know. We know that there's a 26 there. So let's put that in our calculator and see what we get. 154 degrees. Well, if 2A is equal to 154, what is 1A equal to? We need to divide by 2. So we're going to divide this 154 by 2 to give us 77 degrees. Same reason, angle sum of a triangle. We can always double check our answer. If we said that A was 77, then that's 77, this is 77, and we can add them all together and make sure it adds to 180. So 77 plus 77 plus 26, yep, adds to 180 degrees, so we know we answered it correctly. Okay, let's have a look at question C and D, some more challenging ones. So for question C, in order for me to work out what A is equal to, I need this and this one. And then I can just do 180 degrees minus that, and it gives me A. I will call this B, because I don't know what it is, so I'm just going to call it B. And using my knowledge of alternate angles on parallel lines, so here's a Z. On parallel lines, these two angles here, these alternate angles, they're equal. So I'm going to write here that B is equal to 55 degrees. Why? Because alternate angles are equal on parallel lines. Well, now that I've done that, technically I can just replace that with a 55 down here. And now I can work out what A is equal to. Because we have a triangle, and inside that triangle I know all the angles will add to 180 degrees. So A has to equal to 180 minus what we do know. We know there's a 70 and we know there's a 55. So let's put that in our calculator. 180 minus 70 minus 55. That's also equal to 55 degrees. What's my reason for this? Angle sum of a triangle. Okay. Question D. Here we have A inside the triangle. Let's highlight this triangle. But in order to work out A, we need to know what the other two interior angles are. We need to know what how big this is and how big this one is. So let's call them B and C. Let's call this one B, and we can call this one C. So let's work out what each of them are, and then we can work out what A is equal to. Because B is part of this straight line, and straight lines add to 180 degrees, I know I'm going to start off with 180, and I'm going to minus what I do know. I know that this is 116. And 180 minus 116 is 64. So I know that B is equal to 64 degrees. How do I know that? Angle sum of a straight line, because that's what I used. I used the straight line. I didn't use a triangle. I used the straight line. I'm going to use the same thing for C degrees. So first of all, let me just replace B with 64 degrees. Okay, let's work out C for using the exact same reasoning. Here's a straight line. The straight lines add to 180 degrees. So I'm going to start with 180. I'm going to minus what I do know. I know that this here is 155. So let's put in the calculator. 180 minus 155 is 25 degrees. What's the reason? Same thing as before. Angle sum of a straight line. Alright, so we know that C is 25 degrees. So I'm going to replace C with 25 degrees. And now I can work out what A is equal to. A is equal to, well, here's my triangle. They all add to 180 degrees. So I'll start off with 180 and I'll minus what I do have. I've got a 64 and I've got a 25. Let's see what that equals to. 91 degrees. So A is equal to 91 degrees. What's my reason? Angle sum of a triangle, because that's what I used. Okay, let's have a look at the last part of this lesson, which is looking at the exterior angle theorem. Now, the exterior angle theorem states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So here's an example. This Z here, if I want to know how big this angle is, all I can do is just add these two. Always the ones that are opposite. So never this one, never that one. Just add it, two interior ones, and that will give us this one. So if this was 80 degrees and this one was 60 degrees, Z is 80 plus 60, which is 140 degrees. Okay, so that's the exterior angle theorem. Why does that work? You might wonder. Well, it's because if that was 80 and this was 60, using the angle sum of the triangle, this one here has to be 180 minus 80 minus 60, which is 40 degrees. And using here, the angle sum of the straight line, these two angles must also add to 180 degrees. So Z has to be 180 minus this 40, which is technically the sum of those two. Okay, so let's have a look at two examples to end this video. So using the exterior angle theorem, we can see here that A, which is the outside, is equal to the sum of the two opposite interior angles. So we know it's equal to 70 plus 90, which is 160 degrees. For question B, same thing, we can use the exterior angle theorem. We know that the outside one is going to equal to the sum of the two opposite interior angles, A and 50. So if we want to work out what A is equal to, just going to minus 50 from both sides, just a simple algebra. 130 minus 50, that gives us 80 degrees. And that's it for this video. So now you should know how to label your triangle. You know how to classify triangles, how to find missing missing angles in the triangle, and also how to use the exterior angle theorem. Thanks.